Hey guys, it's Miss Vinson. Today we're going to finish up our discussion about the resource market. Now we've looked at how the resource market really is the flip side of the product market that we spent so much time learning about. We've also looked at a perfectly competitive labor market where you have many firms that are competing against each other to try to buy the labor. We've also looked at a monopsony where there's just one buyer of labor or of resources in a market. So in those discussions, we never really had to talk about certain types of constraints. And also in those discussions, the main resource we were talking about was labor. Well, sometimes businesses like to have a combination of workers and physical capital. Sometimes they want to have a certain amount of machines and a certain amount of workers, and that magic combination of a certain amount of machines and workers could equal your most productive output level. But the thing is, trying to figure out how you can be as productive as possible using the least amount of money. So what I'm going to talk to y'all about today is how to find the cost minimizing combination of inputs to where you can still maximize your production. Because all firms want to be as productive as possible, but that doesn't mean that you want to spend a whole bunch of money. So you want to be as productive as possible, but you want your costs to still be as low as possible so that you can keep as much profit as you can. Because it's all about profit maximization. So today we're going to talk about the cost minimization rule. In some books, it's also called the least cost rule, and you have seen something like it before when we did utility. If you remember way back when we were talking about consumers and how their primary goal was to maximize their utility, then what they were trying to do, they were trying to spend their budget and get the most satisfaction they could from those items out of that money. They were trying to get the most utils per dollar. So they were trying to make the most effective use of their budget. And the way that we found that is we looked at the marginal utility of one item divided by the price of that item over the marginal utility of another item divided by the price of that item. So we took the marginal utilities of two goods and we divided that over the price of that item so we could find the marginal utility per dollar, how many utils we were basically getting per dollar. And then we just made our choices based on which items gave us the most utils per dollar. Till finally, the marginal utility per $1 of one item equaled the marginal utility per $1 of the other item with the last dollar spent. Well, what we're doing now is very similar to that, but we're not trying to figure out the combination of items that's going to give us the most satisfaction. We're trying to find the combination of machines and workers that are going to make us the most productive and be the best use of our budget. Let's say that you're the production manager of a company. Well, there may be two constraints that your boss may give you. First off, your boss might say, hey, our Q star is 360. We must produce 360 units to be at our profit maximizing output level. So I don't care what you have to do, but find the cheapest way to produce that Q star, those 360 units. In other words, you got to figure out how many machines and how many workers you have to produce those 360 units in the cheapest way possible. Or your boss could simply say this: we only have this much money to spend. Maybe your boss says we only have $40 to spend. So I want you to produce as much stuff as possible with this $40 budget. So you got to figure out, okay, how am I going to combine machines and workers to get as much stuff produced for this $40 budget as I can? So in these questions, guys, you might be trying to reach a certain production level, like 360, as cheap as possible. Or you might be given a certain amount of money and you just want to make the best use of that money that you can. In either case, here is going to be the setup, the formula for our cost minimizing rule. What we're going to do is we're going to take the extra stuff made from a worker, the marginal productivity from a unit of labor, MPL, and divide that by the price that we're paying for that worker, which is the wage. So you have MPL over the price of L, so the extra stuff made from that worker over the price that you're paying for that worker. And we need that to equal the extra stuff that we get from another unit of capital, another machine. That's going to be your MP, and we're using K for capital, over the price that we're paying for that capital, which would be like the rent that we have for that machine. So that would be the MP, the marginal productivity that we get from that machine, MPK for capital, over PK, the price of that capital. It's just like how we did the marginal utility of one good over the price of that good should equal the marginal utility of another good over the price of that good. We're just saying the extra productivity of that worker over the price of that worker should equal the extra productivity of that machine over the price of that machine. So let's look at this in a chart. Let's work this example out. Say we have a certain amount of workers. So let's say we have 1, 2, 3, 4, 5, 6 workers, and we happen to know the extra productivity that each one of these 6 workers contributes to our overall total output. We see the first worker contributed an extra 50 units, the second worker contributed an extra 40 units, the third worker gave us an extra 30 units, the fourth worker gave us an extra 20 units, the fifth worker gave us an extra 10 units, and the sixth worker only was able to contribute an extra 5 units. What was happening there? Is that sixth worker just like horrible? No, remember guys, it's diminishing marginal returns, right? By the time that sixth worker was hired, there probably wasn't enough tools and wasn't enough jobs and space for that sixth worker to be really productive. So we have diminishing marginal returns or diminishing marginal productivity happening here. So that's what's going on with our workers. Well, we're going to hire some workers, but we also need some capital. So let's see what's going on with our capital. We have a certain amount of machines. We have 1, 2, 3, 4, 5, 6 machines, and we also happen to know the amount of extra stuff that we have produced from adding each one of these machines. So we saw that when we added the first machine, it gave us an extra 100 units. The second machine gave us an extra 90. The third machine gave us an extra 80. The fourth machine gave us an extra 60. The fifth machine gave us an extra 45. And the sixth machine gave us an extra 30. Notice that we do also have diminishing marginal productivity happening with our capital as well. Because as we keep adding these machines, maybe there's just not enough space. I don't know. It's going crazy, right? Maybe they're overheating. So that's just what you have with resources. You always have that diminishing marginal returns. Our task is to try to figure out how we can get the most stuff made with the least amount of money. So what we need to figure out is the marginal productivity per dollar spent on each one of these items. So let's take a look at our labor. Let's say that a unit of labor costs $5 per hour and a unit of capital costs $10 per hour. And maybe our boss gave us a budget of $40 to spend. So we want to take this $40 and we want to see what combination of workers and machines can be the most productive with the money that we have to spend. All right, what we need to figure out is the marginal productivity per dollar spent on labor and compare that to the marginal productivity per dollar spent on the capital, on the machines. So we're going to take the marginal productivity numbers that we just have in our chart and divide that by the price that we are paying for each one of these. So when we look at our workers, we see that our first worker can make an extra 50 units. And we're paying that worker $5, so that worker is making 10 units per dollar. The second worker is making 8 units per dollar. The third worker is making 6 units per dollar. The fourth worker is making 4 units per dollar. The fifth worker is making 2 units per dollar. And the sixth worker is making 1 unit per dollar. What about stuff made per dollar for our machines? Well, let's take the marginal productivity of the capital and divide that by the price we're paying for each one of those machines. So that first machine gave us an extra 100, but we spent $10 on that machine. So 100 divided by 10, that machine gave us 10 units of output per dollar spent. The second machine gave us 9 units of output per dollar spent on it. The third unit gave us 8 units of output per dollar spent on it. The fourth machine gave us 6 units of output per dollar spent on it. The fifth machine gave us 4.5 units of output per dollar spent on it. The sixth machine gave us 3 units of output per dollar spent on it. So now that we have them broken down, how much units of output per dollar we're getting for both your labor and your capital, let's start making some choices with our budget. We want to get as much stuff made for the least amount of money. So our first choice is probably going to be our first worker. Our first worker gives us 10 units of output per dollar spent on them, and we're only spending $5. So that leaves us with $35 in our budget. Our second choice is probably going to be the first machine. Now that first machine also gave us 10 units of output per dollar spent on it, but we had to spend $10 for that machine, so now our budget is down to $25. Our third choice is definitely going to be our second machine, because our second machine is giving us 9 units of output per dollar. But we are spending $10 on that machine, so now our budget is down to $15. Our fourth choice will probably be our second unit of labor, our second worker, because they're able to give us 8 units of output per dollar spent on them, and we only have to spend $5 on them, so now our budget is down to $10. And then our fifth choice is going to be our third machine. Our third machine also gives us 8 units of output per dollar spent on it, and we spent $10 on it, so there goes the rest of our budget. So we've used all of our budget of $40, but we've made choices that maximize the amount of stuff that we want to have produced. Notice how the marginal productivity of labor per dollar at the end equaled the marginal productivity of capital per dollar at the end. They were both 8 units for $1. Well, maybe your boss doesn't give you a budget. Maybe your boss says you have to make a certain amount because by our graphs, we need to have this output level to maximize our profit. Our Q star is 360. Well, we can do it that way. If you look at the numbers in our chart, we would still make the exact same choices. When we chose our first worker, that first worker gave us an extra 50 units of output. And then our second choice was our first machine, which was 100 units of output. So that's 150. Our third choice was our second machine. That's an extra 90 units of output, and so that's going to be 240. Our fourth choice was our second worker, who gave us an extra 40 units of output, so that's going to be 280. And then our fifth choice is going to be our third machine, which gives us an extra 80 units of output, and that's going to put us up to the Q star we needed to reach, which was 360. So we have gotten the most stuff produced with the least amount of money spent as we possibly could. Now you may have some questions that ask you, what should you do if your marginal product of labor per dollar is greater than your marginal product of capital per dollar? All right, well, if your marginal product of labor per dollar is more productive than your marginal product of capital per dollar, well, get more labor, right? Because it's more productive. So you want to get more workers and buy less machines. You want to go towards whatever is more productive. And so in that case, you would increase the amount of labor that you get and then decrease the amount of capital or machines you would get, and that would end up balancing them and bringing them equal to each other. Or if you had a question that said the marginal product of capital per dollar was greater than your marginal product of labor per dollar, well, what that tells you is that that machine is more productive per dollar than your workers are. So go towards the machines. Go towards whatever's more productive. Get more of that capital and less of that labor, and that's going to bring them back into balance with each other so they will equal each other. Alrighty guys, we're going to work some problems with this, but hopefully you can see the similarity to what we've done with utility already. So again, this is another one of these things, like everything else in the resource market. It's really similar to something we've done when we studied the product market. We're just looking at it from a different perspective, but it's the same process. Until next time, I'll see you later.